Precision feeding is a complex feeding system that the birds have to sort of figure out, and it gives them something to do with their mind. So it's a form of environmental enrichment. We used to measure body weight once a week at best. Now, some of our birds, they go into the feeding station 200 plus times a day.
Welcome to Unplugged, the official podcast of the Poultry Science Association. This is the podcast where we strip away the fluff and get real about poultry science from bench to barn. I'm your host, Andy Vance, Executive Director of the Poultry Science Association. This week, we're going to dive into the future of poultry nutrition with our PSA President Dr. Martin Zuidhof at the University of Alberta. Known for groundbreaking work in poultry systems modeling and precision feeding, Dr. Zuidhof's patented precision feeding system is reshaping broiler breeder management, and he's got a wealth of information about the future of technology in the precision nutrition space. This week, we're going to explore how feeding the right bird the right amount at the right time helps improve uniformity, welfare, and data collection, and what all that means for the next generation of poultry science, research, and nutrition. Martin, it's a treat to have you on the podcast. You've been a listener from the get-go as I started shoving episodes at you and said, hey, would you listen to this and give me some feedback? And I really appreciate you being a part of the team and now getting to be on the fun side of the microphone. I wanted to start our conversation with your experience as PSA. You've been a member for quite a few years now, and I'm curious how your relationship with our association has shaped your work as a scientist, as a researcher, and as someone who's been a leader in precision feeding and modeling.
I've been a member for 33 or 34 years. I've always thought of it as my family away from home, my work family. Over all those years, the relationships that I've built there, the networking, the inspiration, almost always I come away with something that I go, wow, that was worth the trip. I was involved superficially at first. I never thought I'd be in the position that I am today, to be perfectly honest. I was the rowdy kid from Canada when I started, and now I'm the rowdy old man from Canada.
They're your words, not mine, Martin. I aspire to be a rowdy old man someday.
I just go to bed earlier than I used to. It's been an inspiring place for me. It's a place where I've been able to share my work and hear from the best of the best and be inspired from experimental design to methods in feeding. And poultry science hasn't traditionally been the leader in modeling, but there's been solid quantitative work that have been done by a lot of members. So it's been a great home for me. I still love going to poultry science every year.
One of the things I find really interesting, and hearing you describe that experience from being a rowdy kid now to being one of our actual central leaders, whether you expected that would be part of your journey or not, here we are. When you think about the different types of members we have, from your colleagues on faculty to our graduate students to industry professionals that you work with really closely in your research program and in broiler breeder management, what do you see as a scientist, the role that a scientific society can play in advancing the industry?
There's all kinds of research people do. Some of it is ready for market when it's done, and some of it is still a long ways off. I thought you were quite generous when you introduced me to say that my research was revolutionizing broiler breeder management. I don't think it is. I think it has the potential to. It has revolutionized, at least for me, the insight that I can gain from the birds that I work with, broiler breeders. Change up a little thing like how you feed the birds. You wouldn't think that much should change, but little things like changing the frequency of feeding because of the perfect storm of birds becoming more efficient every year and lower in fat. We had a perfect storm that when we just gave more meals in a day, birds didn't store fat and mobilize it when they didn't have food in the gut, because they always had a little bit of food in the gut. And that made the birds leaner and they wouldn't come into lay. So you might call my first test of precision feeding an epic failure, because we actually saw lower egg production and chick production from broiler breeders. But we learned a ton about just where we are on the evolution of feed restriction in broiler breeders. There are a lot of presentations that are ready to go for industry. When you're talking about nutrient requirements of modern commercial breeds, or when you're talking about feed additives that can make a real difference as we move away from teen use of antibiotics in
Hmm.
poultry production. Those are things that some of them are fluff, but some of that, as you think critically about what's being presented and get deeper into discussions in the networking times, as a professional in the industry, you can weed through that and figure out what you can try.
Hmm.
It has actually quite a bit of potential, so I'm gonna at least give it a try. It doesn't always work out, the same in a commercial setting as it does in a research setting, but yeah, there's a whole spectrum, and that's good because
Hmm.
for a while I was just going to one particular kind of section. I wasn't being inspired. There I learned that the title of a presentation is not necessarily indicative of what that presentation's value is going to be. So I have actually given up trying to orchestrate my schedule at poultry science meetings, and I just sit in sections that I think would be interesting or inspiring and try not to move around too much. Because now that I'm older and my face is recognized more, it's really hard for me to move from room to room without getting stopped and interrupted and having a laugh or a deeper conversation with someone. So,
Yeah, what you're highlighting there, a few episodes ago, we interviewed one of your colleagues, a former PSA board member and past president, Tom Porter, and Dr. Porter described a similar approach. You go to sessions where you know you don't already know everything because you're going to learn something that might influence your research program. Say, oh, okay. With Tom as an endocrinologist, going and listening to a nutrition session might cause him to rethink something that they're doing in his lab about how the pituitary function of a bird affects their rate of growth and so on and so forth. And here you're looking at it, the opposite way. Maybe going and listening to a talk might make you rethink precision feeding. I think that's one of the real strengths and powers of our professional community. I'm thinking about your particular journey a little bit.
could I interrupt you?
Yeah.
I have $1 billion idea, and I don't have enough time in my career to do it. So I'm going to share it with everybody, and hopefully we can make some progress on this. Through some of my modeling work, I learned that female broiler chickens have more breast meat yield per unit of body mass. They also require less protein,
Mm.
the lysine in particular, but the protein in the diet really fuels the development of breast muscle. Females put on more breast muscle per unit of body mass than males on less protein. If we can figure out physiologically, endocrinologically, what's going on there and have an additive or select for something, maybe we can start with some gene editing and see if we can
Uh,
produce birds that can produce food more efficiently. That's
do
going to have a huge contribution to sustainability, and it's got to be worth billions.
doing more with less,
Yeah.
and fascinating. So, in the logical follow up question is, okay, how did you find that? How did you discover that? Because that's part of what I love about conversations with members like you, and then we had similar conversations with Tom during that episode of the things you learned that you weren't looking for. We were in the lab doing experiment X, and we didn't necessarily
Yeah.
find X, but we found Y, Z, A, B, and C.
Serendipity is my friend. I don't think I've ever had a research project that's gone perfectly. And it's usually through things like the fact that we precision fed broiler breeders, got perfect uniformity, and they had terrible chick production. I learned more from that study than I learned from anything else that I've done in my 30 plus years of poultry research. Where did that idea come from? I guess doing some deep dives into data on feed intake, amino acid intake, and breast meat yield, and putting that into models. If you look at the amino acid efficiency or the lysine efficiency, females are way more efficient than males, and we don't need to give them as much. So, how does that work? What's going on? Is it sex hormone based, right? I dabble in endocrinology. I don't consider myself an endocrinologist, which is why I love to hang out with people like Dr. Porter. But over the years, that question, it just steeps and steeps and steeps. And I've thought about this probably for 20 years
Mm.
and never really knew how to tackle it. but I'm going to throw it out there because I don't want a good idea to die with me. Let's get somebody working on it who might be inspired in that direction. So,
Yeah.
yeah,
Well,
it's just a process.
I love that. And I'm looking forward to the day when Unplugged Podcast gets cited in somebody's dissertation because we sparked the idea that next great breakthrough. So I want to look at your career arc, Martin, going back to those, early days as a rowdy Canadian, as you put it, and getting involved in this area of feed formulation, modeling, and then moving into where you are now in precision feeding and this idea of developing a system to feed the right bird, the right feed at the right time. How did that develop from, where you were thinking you were going in your graduate school days? Maybe you're working on that master's degree and what the industry looked like at that stage versus where you are today. Was it the technology that has evolved that's allowed you to get there? Is it just better understanding of data? How has the field developed in those 30 some years you've been involved?
I used to worry that we'd run out of questions. What I've learned is that the more you know you don't know, right? And need drives innovation. I love the idea of precision feeding, but there was no technology to do it. And I wanted it for research. I really was pushed to identify what the commercial value of this might ultimately be.
Yeah.
And because of that, some visionaries said this idea has enough merit that we'd be willing to invest. And I ended up with an engineer that I work with, Mark Fedoruk, and he's gone out on a limb to help me. I could never have done this without him as a partner.
Yeah.
And we're hopefully going to get this to market someday and get some of his investment back. And like I said, with the idea of the breast muscle efficiency in female broilers, these ideas steep and the opportunity might come along, or you stumble on something that's close, but nobody wants to jump in with you. So you have to modify and tweak and say, how is this not only going to benefit the questions that I want to explore, but how is it going to benefit an end user in the hopefully not too distant future?
Yeah. This idea of precision agriculture, it gets discussed, I think a lot, regardless of your scientific discipline. Certainly, if we were crop science folks, we'd be talking about the importance that GPS has given us, and we have sub-inch accuracy now, and being able to put nutrients in the soil and variable rate fertilizer applications, variable rate applications of any of our crop protection inputs. On the livestock side, obviously, it's I grew up on a beef cattle farm. We're not super worried about precision feeding of beef cattle. Just feed them all they'll handle, and nothing. We were growing up, there was no problem on the farm. You couldn't just feed them harder, just feed them harder, you'll get them there. Well, obviously, if we're in the dairy space, it's a very different discussion. If we're in the swine space, a very different discussion. What have been the biggest challenges to you in developing your precision feeding system generally? And then as you think about that idea of taking it to commercial scale, what are the opportunities and challenges that you see at this state in development?
Yeah, I think in poultry, the biggest hurdle is the value proposition.
I thought you were okay. It was developing an ear tag for the chickens. I was waiting for.
Yeah, no, we were able to innovate through that fairly quickly and come up with another path. The chicken is not a big animal, and it's every individual chicken is not that valuable. Broiler breeders are among the most valuable of the commercial chickens, at least in Canada. I mean, in the US, there's pedigree and grandparents and great grandparents, but they're a fairly small part of the sector. But if your bird is worth $4 a live animal to a producer, you don't want to spend $10,000 to feed 50 of them, because you'll never recover your investment. Your technology will never pay back.
Mm-hmm.
It'll be obsolete and probably broken before you've paid for it. Where can we find a value proposition where it actually makes sense to use commercially? And we think we found one, and I'll be talking about that at the presidential symposium at the PSA meeting. I'll just throw a teaser out there.
I want to think about the data, because you've talked a fair bit about data collection and analysis and the technology. So your PhD work focused on bioeconomic modeling of the broiler supply chain. How did you get engaged in precision nutrition and the kind of decisions that producers make on a daily basis about sustainability and efficiency in the industry?
One of the things that's really challenging about working with chickens is that because they have a high rate of reproduction and they sexually mature at a young age, there's a short generation time, there's lots of progeny. Because of that, genetic progress has been amazing. I've got a paper that's really highly cited on that very topic.
One of our most cited papers ever.
It's in the top 20. Yeah. So if you do research today on broiler response to nutrients, for example, the answer that you get, the recommendations that you get are obsolete by the time the research is finished and published and presented and shared. We need better ways to make our recommendations more generalizable. And models are great for that, right? Because we can just change the genetic parameters when we understand how nutrients are absorbed and used by animals. It's way better to have a model than to have to repeat the research because the bird is changing every year. Its size, its growth rate, its efficiency, its level of fat, all those things affect how nutrients get used and what you need to put in a diet.
Are there blind spots in the current modeling approaches that industry uses that you'd like to see? Hey, people listening to this, hey, if you learn nothing else from this podcast, here are some blind spots you might have in your current approach to modeling.
I think there's blind spots if you don't model. Those blind spots are more problematic. When you try to put the world together in a mathematical simulation, if you're not accounting for something, your number, your answer is going to be way off. So putting a model together exposes the areas where we don't have the knowledge that we need. One of the big values of modeling is to really understand the things that we don't yet know that we need to know in order to be successful. I haven't seen the new NRC, but I'm hoping that when it comes out, there will be a huge step forward in the models that are recommended for the nutritional requirements and matching those to the needs of animals with the feedstuffs that we provide. So modeling, it gives insights. And I think it was George Box, early pioneer in modeling. He said, all models are wrong, some are useful.
Yeah.
And I love that phrase because we're not going to get the right answer. We're going to get variation, especially with a biological system. You know, there's huge variation. You get a little pathogen in your flock, it's going to change everything, you know? So the models that are useful are the models that help us answer questions. What's our best guess at what's going to be the outcome? And then it's a game of probabilities, right? We can use the model to identify potential strategies and then implement those and monitor how we did. You can't do a scientific test of the outcome of a model, but you can maybe make a better guess about what your potential outcome might be and try implementing something new as a result.
Yeah. I think it's a great approach, and I love the quote from Bach as well. I think that's really powerful and help you understand what we're trying to do with modeling a little better. One of the things I always enjoy talking with you about, Martin, we've had some great conversations, both practical and philosophical, about the role precision feeding plays in not just performance metrics, but also bird behavior and maybe welfare outcomes more generally. And I'd love to talk a little bit about how the way we feed birds plays into not just their performance, but behavior and our understanding of the bird and its welfare.
Data helps us to tell stories, and every bird has its own story. Incredible when you collect huge volumes of data on every individual animal, what that will tell you about their personalities. Broiler breeders, our first experiment, we just looked at things like, when are they eating? We used to measure probably body weight of individuals once a week at best. Now we're doing that several times an hour. We have, some of our birds, I don't know if it's for fun or because they're really hungry, but they go into the feeding station 200 plus times a day.
Wow.
And that gives us a ton of information. And we're also collecting feed intake. We have a date and time stamp on everything. We just can decipher a bird's story, right? Like the lights in the house go off at night. We have little lights in the station so the birds can eat 24 hours a day. Most of the birds, their body weight goes up all day, and then the lights go off and they don't get weighed again until first thing in the next morning, and their body weight has dropped. They've defecated or lost some weight due to respiration,
Mhm.
and then they gain again, and then they drop, and then they gain, and then they drop. And every day it's just a little bit higher trajectory. We can see when birds stop eating. We can tell before our technicians notice that something's up with a bird. We can tell from its feed intake and visit history that, oh, something's up. We should see if that bird's got a bad leg. We had one that she just stopped eating for 2 days, and we went in and checked and didn't see anything wrong with her. And then after 2 days, she just started eating again. Those are things that we would never have known. Her body weight trajectory was almost unchanged, right? Like there was some compensatory growth. It was undetectable had we not had all of this high resolution data. I always love that about behavior folks that would come in and just tell the story of what the animals might be thinking. And when you have the data, you can do that with a lot more confidence. From a welfare standpoint, I think precision feeding is a complex feeding system that the birds have to sort of figure out, work, and it gives them something to do with their mind. So it's a form of environmental enrichment. There's just a lot of really interesting things that have come from a welfare and behavior standpoint.
I was chuckling as you were describing, they gain all day, they weigh less in the morning, because you figured out why I always schedule my doctor's appointments the first appointment of the day, because I weigh less at that first appointment of the day than I did at an afternoon appointment. You figured out the secret, Martin. You just ask those athletes. They know all about it. Martin, as we finish up our time together, one of the other things I really find fascinating about your work, and you talked about one of your highly cited articles that delves into this, but you've been engaged in helping preserve some benchmark genetic resources. Really incredible work that you've done there with that historic flock. And for folks who don't know about it, maybe give us just a quick snapshot of your work there. But then what I'm curious about is how precision feeding, or maybe the insights that you've gained through your work there, helped you protect and understand genetic diversity in broiler breeders more generally.
Let me start by acknowledging that I should not get the credit for preserving these lines. Frank Robinson, who was ahead of me at the University of Alberta, brought a lot of these lines in.
Yeah.
He brought in lines that Ag Canada had been preserving for almost 30 years, and their scientists were retiring, right? At
Right.
30 years is a career.
Right.
So by the time they were retiring, somebody needed to take them over. So I don't want to take the credit for that just because I'm very involved now in their preservation, but they're incredibly valuable. I mean, we've collaborated on identifying unique genes that are involved with immunity, for example, that could have value in the future. But one of the most valuable things for telling the story to people about where their food comes from is when you have a benchmark of what the broiler chicken used to be like 60 years ago,
Yeah.
and you can compare those genetics directly because you have preserved those genetics in a random bred fashion. You can do all sorts of things, from genetic testing, immunological responses to pathogens, efficiency of breast meat deposition. That has been incredibly valuable. It's expensive to
Yeah.
keep these lines around. We had a tremendous business director working with the Poultry Research Center at the University of Alberta a number of years back. Her name was Agnes, and she worked together with some folks to develop a program, Adopt a Hen. And if you're in Edmonton, you can adopt a heritage hen. We don't let you take it home. We take care of her, but you can name her. And every 2 weeks when she's in lay, you can take home a dozen eggs, which is about the rate that chickens lay. So that's appropriate. And they pay a fee for the adoption, and an adoption fee. And that has helped us tremendously to raise the funds that we need to keep that going. People have said, right, if you want to preserve something, eat it.
Yeah.
or eat their products.
Right.
Because the reality is that you can't naively think that just because it's nice to preserve genetics, that we'll be able to find the resources to do that. They're a tremendously valuable resource for many reasons, and it's a privilege and an honor for me to be able to be involved in that program.
Yeah, it's one of my favorite parts of your story because it's just like you say, when you reference that article and you look at the pictures of the birds from that flock versus the modern commercial lines. I mean, it just really is striking, tangible representation of the progress that the industry has made and the role science has played in that. One question I always like to ask people is what I call the crystal ball question, what they see in the future in their particular field. As you work in revolutionizing how we feed and study broiler breeders and you take your technology to scale, I'm curious what you think that looks like over the next 5 to 10 years, the innovations that are coming that have you most excited at this stage.
Where are we on the exponential curve of technology development? In the next few years, going to see, I think, some absolutely revolutionary changes in artificial intelligence. And I think that and the development of better sensors, more affordable sensors, technology, AI technology is going to help bring the cost of that down as well. I think we're going to see this type of technology become commercially relevant much faster because of AI. The ability to use that data without necessarily having to have the world's top programmers on your staff, because artificial intelligence will help to solve some of that. Now, there's problems with artificial intelligence too, right? So it's not a silver bullet, but I think the reality is that AI is going to move, in particular, this whole sector with robotics and machines, and we're going to see tremendous improvements in efficiency, and that is going to yield environmental benefits, and it's going to reduce the cost ultimately of poultry products for consumers and improve its safety as well. So I think the future is bright.
Yeah.
There are great opportunities. We have a big responsibility. There's a lot of mouths to feed in this world, and we need to do it in a responsible and sustainable way. If you look at the swine people, they're seeing reductions of 17% in phosphorus and nitrogen emissions. That's huge.
Right.
We used to get excited about like 0.5%. Oh, that's a significant difference, and that's going to make a difference. Well, man, if you actually are looking at the level of the individual when you're making your feeding and management decisions, as opposed to a flock, the positive consequences for the globe, I think, are really, really nice to look at.
It's a powerful way to end the conversation. Martin Zuidhof, thank you for sharing of your insights and your expertise so generously with us. And as Martin referenced earlier, is going to be chairing the inaugural Presidential Symposium at the Poultry Science Association annual meeting and North American Scientific Conference. That is coming up 1 month from now in Raleigh, North Carolina. If you haven't already registered, and hundreds of you have done so already, and we're excited to break bread with you and network with you in Raleigh. But if you haven't yet taken opportunity, you can certainly do so at poultryscience.org. Click on the meetings and events tab. Thursday of PSA annual meeting, Thursday afternoon, the capstone of our scientific program will be the Presidential Symposium. Dr. Zuidhof will be chairing and will be featuring some of the world's top experts in this area of precision feeding and modeling. And with the nutritional focus of our meetings, oftentimes I think this is a really appropriate way for us to kick off our first ever presidential symposium. Thank you, Dr. Zuidhof, for taking that on as a challenge we laid at your feet, and you picked up the gauntlet very capably. I'm personally very excited about it. Friends, speaking of poultry nutrition, next week, a number of us from PSA will be at the European Symposium on Poultry Nutrition in Maastricht. Stop by and visit us along with the editorial team from our newest journal, European Poultry Science. If you're going to be in Maastricht for ESPN, stop by and see us. We will be at the exhibit hall there and look forward to networking with you. And as I mentioned, we're just about a month away from the PSA annual meeting and North American Scientific Conference. So one of the best opportunities to network across all of the disciplines of poultry science. Visit poultryscience.org to learn more about that. Until next week, for Unplugged, I'm Andy Vance.